Okay, guys, year one, this is 4B. We're going to talk about the distance formula. I'm not going to go into a lot here, but because you guys already know what the distance formula is, we've done this before. What it really comes down to is that you have two sets of points here, x1, y1, x2, y2, and distance is the square root of x2 minus x1 squared plus y2 minus y1 squared, the quantities. So you could go through that first investigation there, and if you actually look at this and you want to find the distance, shortest distance between 2 points, you can use the distance formula. But how did they figure that out? Well, it all goes back to that whole idea of a squared plus b squared equals c squared, the Pythagorean theorem. Use that. Obviously, x2 minus x1 will be the length on the bottom. y2 minus y1 would give you the height or the difference. Now the cool thing is, again, you can switch x2 and y2 and x2 and x1, y2 and y1. You can switch the orders around because positive or negative, you're going to square it anyways. So therefore, the positives and negatives don't matter. The cool thing about this is that it does extend to our three-dimensional things. Now we could go through this whole idea, and actually I thought we went over this when we went from one corner of the box to the other corner of the box before we left. And so if you guys remember, here's that formula. When you're going from one corner in three-dimensional up to a different corner of a box, or even a three-dimensional like in this radio tower, it's just the difference in the x's squared, the difference in the y's squared, and the difference of the z's squared. Those are the two formulas that you guys have to know. So let's put these to use here with a problem here. And in this example 4, you can see that they drew a three-dimensional box. It says that the dimensions of the storage box for garden tools in the shape of a cuboid. It is shown in the diagram the vertex A has the coordinates of 2, 3, 4. All coordinates are given in meters. So find the coordinates of R, C, B, and Q. Well, if A, where are we here? A is here, is at 2, 3, 4. Remember, X comes out of the board at you. Y is the one that runs horizontally on the board, and Z is going up and down of the board. And so it's really kind of easy to identify all of the other coordinates. So let's just do B real quick. B is just the X and 0 of everything else. It's not going up, it's not going down, or left or right. It's just coming straight at you. And so that would take on the X value. So it would be 2, 0, 0 for B. Or sorry, it's R, sorry. It's a little fuzzy. I think hopefully you guys see it a little bit better than I do. D, at the bottom corner here, uses the X and the Y. So the X and the Y, that'd be 2, 3, and then a 0. Where's D? It does not ask for D in our list, but D, this point, would be 2 out, 3 over. Notice that C is just 3 on the Y, so it's 0 on the X, 3 on the Y, and 0 up and down. So you can find all of those points. They're listed here. It then wants to know what is the maximum length of a garden tool that can fit in the storage box. Well, that would just be from one corner to the other corner. Now, granted, they chose BR, but BR is not the only option you would have. You could take B, there's your first point, R is your second point, and you could do your subtraction. Make sure you keep the R or the B first. That's your X1s, Y1s, Z1s, your X2s, Y2s, Z2s. Or, guys, it'd be just as easy to use point A here, which they told you. So I could do 2 minus 0, 3 minus 0, 4 minus 0, because I can use the origin, 0, 0, 0. So if you do that, you're going to get the same exact values. And it comes out to that 5.38, as it states there. You can also take a look at C, and it's asking what is the height RQ. Well, the height of the box itself is 4, so from R to Q, that has to be 4. But that would be 0 squared, because that's the x's, 0, no going nowhere. Y's, which would be 4 minus 0 squared, which is 16. Then your add that to the z's, which also subtract out the 0. So therefore, it's 0 plus 16 plus 0, which is 16, square root that, you get back to 4. So that's how you can figure those out. And then part D is find the angle between there. If you guys remember, there was a formula for that. And actually the formula, if you want to go as far as that, it is just SOHCAHTOA. So you have to figure out where is BR and BQ. Well, BR is this one, and BQ is across here. The cool thing about it is that this length across the top is parallel with the ground, and so it would form a right angle with the upright from Q to R. Here. That's a right triangle. And if you're given the values here, now this is why, again, they had you find this value of 5.38 from R to B, so 5.38, and then you can also do the distance across the box across here. So do that, then it means you'll have a hypotenuse and you will have the adjacent, which then means you can use cosine. Or if you don't want to find that because that's longer, they had you just find this, and that's 4. So this, according to angle, I'll make this in a different color. This angle right here, this is opposite and adjacent. And that's sine. So it matters how much work you want to do. There's obviously multiple parts to this. And if you wanted to still find the distance across the top, corner to corner, then you could use tangent if you want. So think about your sides, think about what you're given, and then you can find those values. So your homework, first 2 problems are here, and the last couple are there. Have a great day.